Hello class, welcome to Algebra Lesson 3.1, which is all about relations and functions. By the end of this lesson, you should be able to determine whether a relation is a function. So let's start by looking at some vocab. You might be wondering, Ms. Johnson, what on earth is a relation? So a relation is just another way of saying a set of ordered pairs. So let's say we had the ordered pair 3, 1, maybe 5, -7, and let's go with like 2, 9. All right, so sometimes you see ordered pairs listed kind of like that. That is called a relation, okay? That's all that is. A set of ordered pairs is called a relation. Now, a function is a relation in which each input has exactly one output. So that means if you look here, I have a 3, and the output is 1. So input is always going to be your x values, and then output is always your y. So an example is if I had 3, 1, and then say I had maybe 3, 2, and then I had 5, -7 again, and let's say I still have that 0.29. So it's pretty much the same set that I already had. Do you see how I have the same input, right? I have a 3 here and a 3 here, but the output, we have two different outputs. So this would be an example of not a function, whereas this top one would be a function. Okay, and we're going to talk more about that in just a minute. And then the domain is another way of describing the inputs or the x values, and the range is another way of describing the outputs or the y values. Okay, so I highly recommend get to know this vocabulary, because if you don't know what these 4 words mean, you are not going to be able to do this assignment, and you're not going to pass this part of the test. So make sure you study these. If that means you need to make some note cards so you remember what these words mean, by all means, make note cards. It might be your first time ever making note cards for math class, but it's a good habit to get into, because next year when you have me for geometry, you are definitely going to have to do vocab quizzes and tests. So what a good thing to start practicing now. Example 1, recognize the domain and the range. So we want to look, what is the domain and the range of the function? So I'm going to write domain, and I'm going to write range, because those are the two things I want to list. Now, when you list your domain and range, and you have just a bunch of ordered pairs like this, you're going to do the open squiggly bracket. And if you're someone that is unsure how to make that, here's what my high school math teacher taught me. To make the open one, you do an S, and then you do an S backwards. And there's your squiggly bracket. Okay, so the domain, remember, domain is always your x values. So I'm going to list 1, 2, 3, 4, and 5. One thing to note is you always list your domain in increasing order. The table already had these numbers listed in increasing order, so I just had to copy them down the way that they were. And then the range is 11, then I have a 12, then I have a 13, then I have another 13, and another 13. I don't have to list 13 3 times, I just get to list it once, okay? So my range is 11, 12, and 13. And if you're wondering how to make the closing curly bracket, you do backwards S, forwards S, okay? And again, with the range, just like the domain, you need to write it in increasing order. So your order in these squiggly brackets, the curly brackets, do not have to actually match the table. It just has to be in increasing order, okay? So my domain is 1, 2, 3, 4, 5, and my range is the y values, and we just have 3 different numbers, 11, 12, and 13. Now it is your turn. What are the domain and range of this function? Good luck. All right, for this answer, hopefully you got the domain is 2, 3, 4, 5, and 6. And for the range, you got 0, 1, 2, 3, 4. If you have questions about this problem, please don't hesitate to reach out for some help. I'm more than happy to help you. Example 2, analyze reasonable domains and ranges. So we have a function can model each situation. What is a reasonable domain and range for each function? So our first scenario is we have a hose fills up a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So we want to figure out, first of all, what's our domain, what's our range, and then we want to figure out what is a reasonable, or what are reasonable numbers for each of these. So if I think about a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. Well, I know that anytime I see time, so in this case, like we have something that has to do with minutes. If you have something that has to do with hours or days, years, that is always going to be your domain. So in this example, we have a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So if I'm talking about the domain, I know that domain has to do with x, and I know that I can't pick any numbers that are less than 0, right? I could pick 0 because after 0 minutes, I have nothing in the pool. So 0 is an okay number to include as my domain, but I couldn't do -1 because we don't have such a thing as -1 minutes. That's not a thing that we can do. But it could be any number greater than 0, right? And so the proper notation for this is you do the open squiggly bracket. I'm going to put x, and then you put a bar there, and then you write x is greater than or equal to 0, and then I do my closing curly bracket or squiggly bracket. I just really like the word squiggly. That's why I keep saying it, but the proper name is probably curly bracket. Meh. You know what I'm talking about. Then, as far as the range goes, so we figured out that time was our x, so then our range is going to be our gallons. So our range, we're going to open the curly bracket, we're going to put y, we're going to put that bar, and then I'm going to put y like this. And I know that after like 0 minutes, we're still at 0, right? So we are going to say that y has to be greater than or equal to 0, but what's the maximum number of gallons that we can deal with? We know that we're going to stop at 10,000 gallons. So my range is 0 all the way up to 10,000 gallons. So you can write it like this, or you can use something called interval notation, which is where anytime you have the greater than or equal to or less than or equal to, you use the square brackets, and you would just write 0, 10,000, just like that. So that would be called interval notation. And then here, what you would do is you would do the square bracket to include the 0, and then that would go all the way up, like that keeps going all the way to infinity. And anytime you use infinity, whether it's positive or negative, you do the curved parenthesis. Okay, so that's another way of writing it. Let's look at the next question. We have a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. Oh, I forgot to capitalize that. My bad. One table can accommodate 4 chairs. So my domain, I'm going to use tables, right? Because the number of tables impacts or determines the number of chairs, right? So the domain is always the number that determines the other, like the item that determines the other. So in this case, the domain is the number of tables, and the range is the number of chairs. So my domain is going to be, if I do this curly bracket, I'm going to do x bar and then x. Number of tables, I can't have less than what would be a reasonable number? I can't have any less than 0 tables, right? It is possible to have 0 tables. Maybe I just opened this restaurant and I haven't, or just bought this restaurant and I haven't gotten tables yet. So I could have 0 tables. Or maybe I've had this restaurant for a while and I have 10 tables, right? There's no set amount that I necessarily have to have. Then for the range, I'm going to open my curly bracket. I'm going to do y, and I'd say that the fewest number of chairs I could possibly have would be 0, right? If there were 0 tables, there would be 0 chairs. And then the biggest number, or the biggest number of chairs I could have would be 4 per table, right? So if I had 1 table, it'd be 4. If I had 2 tables, it'd be 8. If I had 5 tables, it would be 20 chairs. If I had 100 tables, it would be 400 chairs. So it's 4 times however many tables there are. So you can sometimes use a variable inside your range to determine how many of something that you could possibly have. Okay, so then if you wanted to write interval notation, again, this one would still be square bracket, comma, infinity, curvy bracket, or we could do square bracket 0 and then 4t square bracket. Okay, those are 2 different ways to write this answer. Okay, now I want you to look at this problem. So what is a reasonable domain and range if a bowler pays $2.75 a game? Good luck. All right, so for this problem, hopefully you said your domain is going to be anything bigger than or greater than or equal to 0, because you could go to a bowling alley. Maybe you were just watching a friend play. It's not nearly as much fun, but maybe that's what you did. And so you could say x is greater than or equal to 0. And then the range, we would have 0 would be the cheapest, right? If you didn't pay for any games. Or maybe you did like 10 games, so you do 275 times 10. So what you can actually do is say 0 is less than or equal to y is less than or equal to 275g. And actually a better thing to do here is, instead of using a different variable, and I should have done this on mine too, my bad, you should use x, because that's the number that you're going to be plugging in. Is the x represents the number of games. So then you do 275 times x. And I should have done that with the chairs, the table and chairs too. But that is how you'd find your domain and range. So I wrote them both as like the curly brackets and also the interval notation. Now, let's finish talking about these 2 problems. We want to figure out, is the domain for each situation continuous or discrete? So continuous means that you have a line, you can get like decimals, you can get like in between things, and discrete means that you can't. So, for example, if we talk about that hose filling a 10,000 gallon swimming pool again at a rate of 10 gallons per minute, say that I have been filling the pool for, say, 100 minutes, because that's what we have here, then it would be about 1,000 gallons. Maybe I've been filling it for 250 minutes. So you see, I can do kind of in between things. I can do halves or quarters or thirds. But if we look at letter B, I can't have 2.5 tables, right? I can have 2 tables or I can have 3 tables. So that means that there's nothing included between those dots. It's just those dots as options. And that's because I can't have partial anything for tables, okay? So when you have a line like this, that is considered continuous. And when you have dots like this, that is called discrete. So these are 2 words that, again, you're going to want to study up and make sure you know what they mean. Otherwise, you're not going to be able to do the homework or do this part of the test. So make sure you know those words. Okay, let's look at example 3. Classify relations and functions. Is each relation a function? If so, is it one-to-one or not one-to-one? So first of all, remember, in order for a relation to be a function, each input must have exactly one output. So that means when I am given a list of ordered pairs like this, I need to look at my inputs first. So I want to look at my x values. I have an x value of 1. I want to look to see, do I have any other 1 x values? So does my x value repeat? I have a 5, 7, and an 8. No, so that 1 does not repeat. What if I look at 5? I have 5, 7, 8. The 5 does not repeat. And if I look at 7, 7, 8, 7 doesn't repeat. Since none of those x values repeat, this is a function. And now, in order to know if it's one-to-one or not one-to-one, one-to-one means that each x value has a different y value. So this is where you look to see, does my y value repeat? So I have a 2, a 6, -1, and 0. Since none of those repeat, this is considered a one-to-one function. All right, now let's look at letter B. This is called a mapping, and if you were wondering what on earth this means, let me show you what this would look like as ordered pairs. I would have 1, 17. I would have 2, 17. I would have 3, 11. 4, 10, and 5, 10. Okay, so the way I got that was you do, this is your x value, this is your y value. So x, y, x, y, x, y, x, y, x, y. So that's how I got each of those ordered pairs. Now, I'm going to get rid of the ordered pairs and let's look at the mapping to figure out, is this a function? So first of all, I only have one number going from the 1. I only have one number going from 2. I only have one number going from 3. I only have one number going from 4, one number going from 5. Or you can say, I only have one arrow from 1, one arrow from 2, one arrow from 3, one arrow from 4, one arrow from 5. That means that this is a function. And then, in order to know if it's one-to-one, I need each of these inputs, each of these x values, to have a different y value. So 1 goes to 17 and 2 goes to 17. So since those both give me a 17, I would say this is not one-to-one. This is not a one-to-one function. Okay? Same with, I have a 4 going to 10 and a 5 going to 10. So that also tells me that this is not a one-to-one function. All right, I want you to look at this mapping and I want you to tell me, is this a function and is it one-to-one? Good luck. All right, for this problem, hopefully you saw that 3 gives me both a 6 and 3 gives me a 7, so it's not a function. And if something is not a function, it actually cannot be one-to-one or not one-to-one. It is simply classified as not being a function. All right, I want you to look at this graph now and determine, is this relation a function and is this one-to-one? Good luck. All right, for this example, hopefully you ended up with yes, it is a function, and yes, it is one-to-one. Now, something that you learned back in pre-algebra that I will refresh your memory on right now is if you're ever given a graph of a function and you want to know, is it or a graph of a relation and you want to know, is it a function, there's something called the vertical line test, meaning if I draw a straight up and down line, it should only ever cross the graph, like what was drawn on the graph, once. So you can see it doesn't matter where I draw my vertical lines, this is only going to hit the graph one time in any given location, even if I went in between my two numbers. Okay, see, it only ever hits once. Okay, so that tells me right there that is a function, because the vertical line test, which is sometimes abbreviated VLT. So vertical line test. And then one-to-one, I know it's one-to-one because for every x value I put in, I'm only getting one y value out. Okay, so this is a function and it is one-to-one. All right, let's look at example 4. Identify constraints on the domain. The diagram shows shipping charges as a function of the weight of several online orders. Based on the situation, what constraints, if any, are on the domain of the function? So, first of all, if you're shipping something, no matter what, you know that there has to be some weight there. Even if it's something really light, it still has weight. So I know that it for sure has to be greater than 0, but it doesn't tell us that there's a maximum weight of what can be shipped. So I'm going to say x has to be greater than 0, right? I can't put greater than or equal to 0 because I can't have something be 0 pounds, okay? So x has to be greater than. So in interval notation, that's when you do the curved bracket because it's not included, and then you would do curved bracket for infinity. And that's all that this question is asking for. It's just asking what constraints exist for the domain. So that's all that I have to list for this problem. Question 4. Margaret has a monthly clothes budget of $50. She maps the amount of money she spends each month to the number of items of clothing she buys. What constraints are there on the domain? So this is the same thing as the last problem we did. So we're just looking at the domain, and I want you to tell me, what are the constraints for the domain? Good luck. All right, hopefully you ended up with x has to be something between $0 and $50 for this example. So we have $0 and $50. If Margaret chose not to buy anything that month, that's fine. She would spend $0. And maybe she found a bunch of things she really likes, so she spent $50 another month. So you would include 50. So if I wrote it in interval notation, I would do the square brackets, so that way I know that they are included. Or you could write it this way. Both are acceptable answers. You just have to pick one of them. And here is the summary for this lesson. If you have any questions at all on this video, please be sure to reach out for some help. I am more than happy to help you, and I hope you have a great day.